Hi everyone, so we're taking a look at adding and subtracting rational expressions. This is part 1 and it's in page 385 in your textbook. So in order to take a look at it, let's review first how to do adding, subtracting in fractions, but I will be talking about how I would do them keeping in mind we're going to use that method in rational expressions. So you may do this in a different algebraic way, but the steps that I will be using would be so that we can then translate them into the ones that we're going to use for rational expressions where they're actually less or no numbers. Okay, so in this case, if we take a look at that first example, the first thing I would want to do is I would want to make this as a common denominator. It's as easy enough. There's nothing in common between 3 and 5, so we know it's 15. So what are we trying to do with this fraction is we're trying to make both denominators over 15. Okay. What does this first fraction need in order to become a denominator of 15? We know it needs to be multiplied by 5, and so is the top. So that becomes 5 times 2 is 10. And then the second one needs to be multiplied by 3, and then plus this becomes a 6. So the next steps you would do is you would make the more common denominator 15. 10 plus 6, the answer is 16 over 15. And the last thing then you want to do over there is you want to make sure you can reduce it further, which it can't, so this is the final answer. In this example over here, I'm going to do about the same thing, but I'm going to just approach it a little bit more in detail. So again, if I was dealing with numbers, I would just do it much quicker, faster way, get a common denominator, maybe not do so many steps. But the reason I'm breaking down the steps is, again, so that we can actually use it for rational expressions. So when I see numbers which I know there's a lowest common denominator kind of amongst them, what I would want to do is I would do prime factorization of my numbers. This is something that we can do with our rational expressions itself when we factorize them. So I would do that with everything. And then I would try to get the common factors between them. So remember, we're trying to find the lowest common denominator. So I'm going to try to find the common factors between them. So first thing you want to do is maybe try to get a common factor, if possible, between all 3 of them. So when I look at this, I see there's nothing really common in all 3. So if there is one, you would write that down. But if there isn't, then our next best thing is to try to get common factors between at least 2 of them. So like I can see that this 3 is common between 2 of them. This 2 is common. So when you pick something common, you only write it once. So when I saw that this is 3 is common, I represent that by 3. This is 2. Then another 2. And now I see there's nothing common between any of them. So this is represented on its own. So I will also include that. So common ones and the alone ones, everything gets represented. And if you multiply, this is 24. I'm pretty sure when you looked at these numbers, you all knew it was 24 anyways. Okay. Another thing in rational expression that is better to do is not to do them this separate way, but to go straight into putting them on a common denominator. And the reason is because it works better with our distributing of the signs. So I would not recommend doing this. Sometimes it creates more confusion. I would say, okay, everything needs to be a common denominator 24. So what does this 8 need to become 24? It needs a 3. So 7 times 3 is 21. What does this 3 need to become 24? It's a 8. So the top also gets 8. So negative 2 times 8 is negative 16. See how I'm including my signs as I'm multiplying? The 12 needs to be multiplied by 2 to become 24. So that means this will also get multiplied by 2. Positive 5 times 2 is positive 10. And then I will combine them, which will give me 15 over 24. And the very last thing is try to reduce them. So in this case, it will become 5 over 8. Okay, and that's my final answer. So the steps when we're taking a look at whether it's rational expressions or we're trying to do rational numbers is we try to find the lowest common denominator. we express each rational expression as an equivalent, so that we try to make sure we multiply them with a number so that they have the same denominator. And then we combine them by adding, subtracting, and the last thing is we try to reduce them in the lowest form. So we're going to now try to apply them. Between this lesson and the next lesson, the questions will just start with easy to become progressively a little bit more complex, but the idea will stay the same. Okay.